Your test is next Tuesday, right?
Yep.
Yeah. Yep. So what is the escape speed of a satellite located at the moon's orbit? Jonathan, look up the Earth-Moon distance, please. What is the escape speed of a satellite located at the moon's orbit in meters? I mean, okay, just look up the Earth-Moon distance. What is the escape speed of a satellite located at the moon's orbit about Earth? Assume that the moon is not nearby. Okay, so here is Earth, and here is the satellite. So here is the object, and what we want to do is, so it's at rest at that point, what we want to do is throw it such that it escapes. Okay? And the distance it is Earth-Moon distance. Okay? Also, this could be the escape velocity for Earth. So if that is the moon and it's at rest, and you don't like the moon anymore, what speed do you have to chuck the moon at so it escapes? All right, that's the problem. Now, when an object escapes, what you want is for it to go to infinity and come to rest. Okay? And if it's at infinity and it's at rest, it has no kinetic energy and no potential energy. So its total energy needs to be 0. Okay? So the energy is, so at this point, the escape velocity, we'll call it m. This is Earth. Okay, its kinetic energy plus its potential energy should be equal to 0. Okay, and so you can use this 1/2 mv escape velocity square equal to gmm by rem. So escape velocity, and you will have this expression in your notes. Okay, so what this expression is telling you is to escape from this distance from this object, to escape from this object from this distance, you need to have this velocity. Okay, that's what we're saying. All right, I'm going to run out of room here, so I am going to add another page. So let's add another page. Okay, what did you find out, my friend?
238,900 miles.
Ha. Miles. This is I wanted it in kilometers, but anyways, our friend is not being cooperative, so we will. And 1 mile is 1,600 meters. Okay, so yeah, so we want in meters. G is 6.67 into 10 minus 11. I just worked out and my hands are still shaking. And mass of the Earth is 10 to the 24 kgs. And this whole thing to the power half. Okay, so that's the escape velocity. So if you wanted to get rid of the moon, this is the speed at which you would have to chuck the moon. Okay, if it were at rest. So, okay, again, like we keep saying, in this business, it's best to take care of powers of 10 first. And you guys know what is the escape velocity from the surface of the Earth? It's 11.2 kilometers a second. Okay, So if you're chucking something from a little further away, it should be less, but roughly of the order of kilometers a second. Okay, so it should come out in kilometers per second. Okay, so keep that in the back of your mind. So there's 11. This is 24. 24 minus 11 is 13. And so I'll take care of the powers of 10 here. This is 3 and 2 and 5, 8. So this was 13. So I'll make it 14. I'll make this 0.6 and make that 14. 14 minus 8 is 6. Half of 6 is 10 to the 3. Okay. So I hope you got that. There is the kilometers per second that I was talking about, 10 to the 3 meters per second. And now let's take care of the other factors. 2 times 6.67 times 6, no, 0.6. Remember we borrowed a 10 from there, so that's 0.6 divided by 2.39 times 1.6 to the power half. Okay. All right, so let's find this value. Okay, so what this is saying is the escape velocity is 1.5 kilometers a second. So if you wanted to lose the moon and if you wanted to chuck it from the surface of the Earth, you'd have to chuck it at 11 kilometers a second. But from a quarter of a million miles away, you only have to chuck it at 1.5 kilometers a second. Okay, so that's what we're saying. All right, any questions on this thing? All right. So here